Welcome to the SharkFest podcast. My name is Roland Knall and I'm one of the co-developers of Wireshark. In this podcast, we will discuss all things about Wireshark as well as topics from the world of packet analysis and SharkFest, which is our packet analysis and developer conference. You will meet interesting people and learn why the truth is always in the packets.
Good morning, everyone. To something we're gonna try this year for the first time. It's our very first SharkFest panel. We're gonna have a short discussion about, as you can see in the title, the future of packet analysis. And I want to give you a warm welcome to our panelists. So on the left, we're gonna have Chris Plume, software developer and also known by his synonym Space Packet, veteran of the industry for 25 years, from our main sponsor LiveAction. Next to him we have Laurent Schirck, CTO of Profitap, also one of our sponsors, also with over 20 years of experience. Then we have an oddball, Nathanael Weill, data scientist from Agile, but originally with a background in biology, you know? Wireshark always catches everyone. Stephen Donnelly, here since the very beginning. I think he was here before even SharkFest was invented. CTO of Endace, over 20 years of experience. A woman who usually wouldn't need any introduction, Dubois. Getting paid to capture analysis traffic since 1997. So if you think you have experience, talk to her. And last but not least, Ross Bagurdes, an engineer and an IT educator, with another very impressive number. He taught over 1 million students the art of IT engineering and packet analysis. So, what we're gonna do today is we go through some topics about the future of packet analysis, especially, but also on some ideas that have come up over the past few years. And I'm gonna start in the middle with Nathanael, you, about the AI's role in network resilience. What do you think about that?
I have been in many different fields. It's always been through different steps or phase. The first one is to be descriptive, to understand what is going on and get some rules out of it. And that's helped for many times to build expert system, for example. And the second phase is to be predictive, to understand how we can proactively prevent some problem and improve the resilience. And the last step is to be prescriptive, so like that, to be able to proactively act on the network without human interaction. So this automation is where the resilience is going to come. There is a couple of algorithms that are today available, such as reinforcement learning, and to help on the automation to optimize the resource of the network. And I think in the future we'll see that more and more. It's going to trigger such self-healing procedure. The network would be able to actually act on itself and react on threats and many things. The last point I want to say is like recently there is a huge increase in compute power, and for many times we use aggregated data such as time series to understand what's going on in the network. But today, thanks to this compute power that is increasing, we can go lower and work on the pickup directly. I think this is going to be the future. I'm going to help to go even better at improving resilience.
Catching on the topic of compute power, and by the way, we can use those mics, I think, a little bit easier to handle. No, just want to put it to Stephen. Compute power, one of the things you can do is optimize the algorithms, the other one is go to the cloud. So how do you see the cloud affecting the future development in analysis and packet capture?
Sure. So I think what we're seeing is that, cloud has been around for a long time now. We're 10 years into cloud or something like that. But a lot of organizations have been quite slow to move. So a lot of companies, large organizations in particular, have not really started shifting a lot of their workloads into cloud. And what we're starting to see now is larger organizations literally talking about shutting down their physical data centers. So you no longer have networks that you can tap, that you can put spans in and port mirrors and so on in your physical data center. You're paying for somebody else to do that networking for you. And that does make it a lot harder to actually get at the packets. And also, things are becoming disaggregated. So you no longer have these single points of access where you can actually see all the traffic coming and going. And a lot of your own services are actually SaaS services. They're not even being provided by you. You may have control over the endpoint, but not the actual service itself. So you're limited to where you can capture the packets.
But Laurent, this will make it very difficult to tap networks, to capture, to get aggregate data. Where do you see this going in the future? What are the challenges that we're facing there?
Yes, that's true. It will be very difficult to find a single point, physical point where we can tap. So basically we need to tap at the endpoint, probably, or at the edge if we talk about branch offices. That's actually what we developed the last years with IOTA, a small probe to be placed in branch offices. And in future, we want also to develop solution for cloud to tap inside virtual servers.
So let's say we have this vast amount of data. Let's say we have this vast amount of information available to us. One thing I can expect is that analyzing that data, or at least solving issues with the customer, will get more and more difficult due to that, right?
That has always been difficult. Stephen and I were talking. I actually got to sniff on my first long-term capture device, which is what I call products like Endace and other vendors who do that, back in 2004. So this is not a new issue. It's been going on forever. The key is either A, I have incredibly awesome hardware and software that does the indexing for me and pulling it for me back to, we need better computing and, hardware that's somewhere else, to exactly like anybody who sat in Sokka's class and approaching it from the command line. And so normally what I do, so when I look at a PCAP, I'm looking at, more than 25 gigs at a time normally. And pardon me. So for me, it is TCP dump filters, and I use that to scrape out what I need. And I do that because TCP dump is faster. Then I go down to a smaller file, weed out what I want or weed out what I don't want. And then I'm looking at Schirck to pull out finer points. But it's a process to do it manually. But once you know how, 2 command line tools. What does that mean, people? Scripting. So it's just a question of, yeah, exactly. So it's just a question of, do you know what you want to look for? But don't be afraid of incredibly large PCAPs. I don't think a PCAP is large until it's over a gig. I don't think it's really big till it's over 100 gig. Not that, others deal with terabytes at a time. For me, I just have to have good software when I go to terabytes. But yes, just narrow it down. TCP dump, the filters are, what we have in dump cap, only more. And then narrow it down with either, edit cap by time or narrow it down with Schirck by very fine points. Like my response time is greater than X.
But this will also face a challenge in the development of tools, right, Chris? I mean, where do you see those cloud-based networking analysis tools evolve from the development point of view?
I think there's a couple ways to look at that. With the cloud, we're kind of starting all over. We're also used to on-prem, so we've got that down. And now with the cloud, you got to look at it from, there's a Moore's Law point of view, there's AI, there's quantum computing. So when it comes to development tools, what are you going to be developing those tools for? Are you going to be developing those tools for the hackers that are really excited about the cloud, for the developers who want to make it faster, to the developers who want to make it more secure? So there's going to be a whole new, well, not necessarily category of development tools, but now we're going to be applying those development tools all to the cloud. So there's going to be a lot of opportunity for the tools and the applications. We're clearly, as we all know, we're going through a revolution here. And so we get to kind of start over by applying the same kinds of tools and applications to the cloud. And I find it really exciting. And we're working with a lot of customers who are migrating to the cloud. Migrating is the wrong word because they're running to the cloud as fast as possible. And so it's an opportunity for them to save a lot of money, but it's also, as we all know, working with these customers, there's a lot of performance problems, a lot of security problems. So for development, there's going to be new opportunities for all of us, and anybody coming out of college right now definitely has a job waiting for them.
Well, yeah, thank God for that. I don't think we will have any issues in our fields to field people into certain areas, but those people will need, besides the university applications and the university teachings, they will need training. So how do you see, especially with those applicants and those applications coming from the cloud, from the iPoint, how do you see future training evolve around these new types of networks?
Yeah, I mean, this is a issue on multiple levels. You have what Stephen was talking about yesterday in his presentation, where doing a capture in the cloud to do analysis, this has a new cost that we didn't have before. So we need to teach the engineers how to best utilize that, right? So that we're just not running captures all the time, even though we can be used to that in a data center. So we have this education at the higher level, but then at the same time, the cloud itself is just somebody else's data center, right? So there is a whole fleet of engineers and junior engineers and basic techs that are now running that cloud that are going to need education about protocols and how to analyze and all of this. So when I see this, I see a whole new population of people that need a very varied education about protocol analysis and how to interpret it. So at the lower level, you need folks that can understand real basic stuff. You need folks that can have intermediate skills and higher level skills, also skills that can allow people who have applications in the cloud to better troubleshoot them with more limited tool set.
But you raise an interesting point, because when you start out, us as experts and us who are very close to the field in various parts of it, actually, we anticipate new trends, we anticipate new situations coming on. But I think, AI being a buzzword, everybody had AI on the plan for the last 5 years. Nobody knew how. Cloud is a buzzword for the past 20 years, and nobody really at the beginning knew how. How do you anticipate a new trainee, a new student to identify which sectors they should focus their training on, and how do you anticipate training evolving around new ideas to be present?
Yeah, I was talking with somebody from Beyond yesterday, and our conversation was about how AI is being used in their product to troubleshoot telephone systems and communication systems in that realm, and how AI is going to allow an engineer to process and analyze a lot more tickets, so to speak, than before. At the same time, this goes back to my point of needing varied levels of skill sets for that, right? You need higher level engineers that can interpret that AI that's coming in. And so you need this high level training, that's this really heavy engineering training. But then to do that, you're also going to need a bunch of more junior engineers that are going to need the skill set to look at the basic stuff, to get the simple stuff out of the way that AI catches. So to answer your question, I don't think it's going to be up to the individual to know what level training they need. I think organizations are going to have to start creating training programs specifically for the positions that allow them to be the most effective. So these organizations are going to need to come to places like SharkFest and Wireshark University to say, we need this level of training for these 1,000 people and so on.
And so often what I see in my classes is they want to mix that layer one, tier one engineer who's doing help desk tickets, mix them in a class, mix them in a class with your, tier three guys because they want to fill the class. And the speed that you teach tier one and the speed that you teach tier three, it's very difficult to keep everyone interested and keep it flowing. So corporations need to cough up the money to do it, more. And that's where classes that Ross teaches on a streaming platform come into play. You can have one set for a certain job type, one set for an advanced type. And then we don't have to worry, how many people do I have in class? As much as we love to teach in person, it is more efficient to go ahead and have those classes streaming.
I just want to add something on what you said. The trend, it was a debate for a long time. Should we start with AI and move to specialized domain? Or should we start with a specialized domain and I feel like for the past maybe 5-10 years, the most efficient is to go from a specialized domain and adopt AI, because we see a lot of things that on the press that are crazy complex and we don't always understand. Actually, it's really easy. And the main trend in AI is actually to democratize it. Today, we are at a level where people are mature enough to understand who's going to do what and how to cooperate. The only thing is now we are facing 3 challenges. Are we going to tackle telecommunication domain, cloud domain, or AI domain? And I feel like any other domain is going to go through cloud, big data, and then AI, because you cannot do anything without data. So data engineering, machine learning engineers, MLOps, AI, applied AI people can all come from the telecommunication domain. That's my feel.
Because it is complex. Yeah. All those back channels, it's incredibly complex. Yeah. And when the application is developed or the application is changed or tweaked to make it fit that company, it is extraordinarily complex. As engineers, we want to hey, can you ping it? All right, can you ping the port? All right, I'm done. But then you get into more of the application layer. Layer 4 through 7 is where I live. And it is a whole different world. And so now in the cloud, it becomes, because we don't own it. And it becomes much more. So it's a wonderful approach to do one thing, do it really well, then bring it in.
One thing that I'm seeing is when it comes to cloud computing, on LinkedIn a lot, I'm seeing everybody's getting certifications for cloud, and that's great. That means companies are sponsoring training for cloud computing, so it's become very institutionalized, which is great. Just about everybody I know who's an SE or a network engineer has some kind of cloud computing training. But I think where we are when it comes to using AI for applying it to cloud computing or using AI for anything, we are still early adopters is what I don't know of any training class or any certainly corporate sponsored training for AI. And I wonder how long it's going to take before companies, most companies have outlawed AI. You're not allowed to use it. So although we're all talking about it here and we're using it anyway, it will be interesting to see how long it takes before that becomes sponsored by companies and is not something you have to do on your own.
One issue we have with cloud and one issue we also have with AI training is that the data amounts are going to grow exponentially in the future, because you need that to train, you need to analyze. Now we have 2 experts from companies here on the stage who have products in that area, and I want to give it to Laurent first. How do you see the companies dealing with products that can handle such data growth, and how do you see the companies handling the eventually trade-off, what to capture, what not to capture? Are there any limits to come, or do you see it going forward like Moore's Law?
I think, yes, the volume of traffic will grow, that for sure, exponentially probably. But volume of traffic we will monitor might be more efficient in future, because basically when you place a tap on a physical line, you get all the traffic. Then you can put some optimizer like network packet broker to filter down, deduplicate, load balance. But if you think about tapping in a cloud, you maybe have an agent, get the traffic directly from the agent. You can implement a filter directly in it. So you get directly the traffic of interest. More efficient, probably.
But Steven, wouldn't that introduce massive security issues? Wouldn't that introduce massive security concerns? How do we address those?
Yeah, so filtering is great if you know what you're looking for. So, you know, the problem is always the 0-day issue, you know, which is why we like capturing all the packets if we can. So you try and capture everything that's on the network and store it so you can look back later to see what happened, because you don't know until something gets announced what traffic is good and what traffic is not. And because network speeds continue to increase and data volumes increase with AI, the average house has got dozens of devices these days, and packets are not getting bigger, right? So if the network speeds are going up and the packets are the same size, that means you're getting more and more packets, and that makes the analysis more difficult. So I think it is a problem. I think, you know, filtering, compression, all of these things help, but network speeds are probably increasing faster than storage, and that will continue to be an issue.
I want to switch a little bit to back to the question about future skills and stuff, because I think most of us here are interested in learning what can we do, where can we prepare ourselves for the networks to come or companies to come. Now, one interesting side topic that I learned today actually is that your background is in biology. Do you think that in the future I don't want to say cross species, but cross professionalism people have an edge advantage, that it makes sense to invest in areas that are only adjacent to IT stuff?
So AI, it's not one job, it's an ecosystem job. Depending on where you want to land, I feel like it's a big advantage to know the domain before going to AI. Just because the one that understands the most the domain gonna be the best at representing the data in the proper way. And actually the fact that we have a lot of data is a good news for us, because AI is really data hungry. And this new approach of storing everything in order to build better models, it's going to trigger new jobs also. Because in the past, we tend to build everything from scratch. And thanks to like recent evolution of packaging and the domain expertise has been in place for maybe 10 years now, and things are really well defined. So for a newcomer to the domain, the barrier of entry is much lower. So I feel like it's the same thing as before when people start to use computer. We use computer because now everybody is using computer and we don't need to have a training for that. AI, I think, gonna be the same very soon. So it's gonna be in any kind of domain expertise. You're gonna have like small usage, like you know how to use a database. You're gonna be able to use AI the same way.
That's definitely true. Now, people, especially people in the IT engineering departments, are usually, they have a saying that we don't really associate well with other people. Now we have a few, I really try to phrase that diplomatically.
So do you mean that soft skills are important? Yes, soft skills are important. Yes, AI could do that for you and go ahead and take the proper tone, because we all want to say, it's your fault. You own that box and it's your fault. Could you fix it? That's what we want to say, but we can't say that. So it is nice to have AI generate that proper tone in the email. Yeah. So the fun part, the engineer part, is figuring out whose fault it is, why is it slow, and then whose fault is it? That's the fun part. But the goal is still from a business perspective is to move forward and, sell stuff, make our product, what have you, is to go ahead and make money for the company. But so it's eventually to solve the problem. But it is fun to go ahead and figure out whose fault is it when it's not your fault. But yes, AI is a beautiful thing to generate those tones for emails. But hi, we still have to talk to people. Yeah. Yeah. Well, for now.
You have to.
Well, there's another side to this too, because not everybody is going to be good at the soft skills or even be able to learn those or have a desire to. In my days of IT management, I had staff that I had to protect, right, to make sure that people weren't constantly going up to them and talking to them because it made their life difficult. So, in a education sense, I think sometimes in a business sense, sometimes we need those folks that don't have the great soft skills, but are completely content being in their office, cubicle, home, whatever, looking at packets, analyzing stuff, and coming up with solutions. And maybe we need to push off the soft skills onto some other entity, so that they can communicate exactly what Betty's saying in the best way possible, that it's your fault, and not have that person that's in their closet or in their basement hacking away at something to solve a problem communicate, because they might be rude.
Yeah.
I love this topic, just real quick, that because we're all looking at it and we have to deal with this, the soft skills, the relationship with the person whose problem it really is. And I actually just wrote an article about this on LinkedIn called Bridging the Gap. And so one way to look at it is, how to tell somebody else it's their fault. The other way, and this is what I use AI for, is bridging the gap, which is using AI, using ChatGPT to go from my perception of things, which is packets, which is what I see on the wire, to what the problem actually is over on the hardware, and some router or switch or something, and how to explain that to a person so they're not offended. So once again, getting back to the psychology of it, but also in a technical way that helps them to solve the problem.
And I like Ross's comment of, hey, as a manager, it was his job to protect the people that don't, we don't all work and play well with others. There's a reason I work for myself. I don't like to talk to people, actually. But so that is very important from a management perspective. Having 300 people on a bridge call is not a good idea.
And the voice over IP is probably going to be really slow, because there's going to be a lot of jitter.
Seriously.
RTP packets probably aren't marked for QoS.
No, they're not. They're not. Yeah.
So guys, you have your next excuse for the Zoom meeting why I couldn't attend. Well, the voice over IP aggregation, that was just horrific. I couldn't do that. It was not good. One way, and I really like that the points you made about protecting people and about it's not for everyone, and that's absolutely fine. That's absolutely okay, and we still need everybody. We don't need to separate, or don't say, okay, you don't have those skills, it doesn't work. But one thing I learned from my own experience is the better the data is prepared, the easier it is to convince somebody who doesn't know how to shop with in our language. Now, how can the tools help with that? What would you see is an ideal way of progression in the development of aggregation software or monitoring software? You just launched a new tool. You already have a new tool. What would you say is one of the problems in creating a tool that's better in communicating what you see on the network for people who are not as experienced in the network management?
It's always difficult to communicate the right information to the right people, especially in this domain where information, you can have any sort of information, a problem can be anywhere. So it's difficult to synthesize the information. We try to do it as much as we can with metadata, and to provide a flexible platform where the user can take the data from any perspective and search by himself. So we are not predefining anything in our UI, for example, because we don't want to be fixed in a certain use case or certain problem finding. And so actually we try to be more flexible in that way, but it's always a compromise between being flexible and being synthetic.
It's an interesting question. I think from a tool point of view, we're starting to move away from trying to build a single tool that does everything, right? Trying to build a tool that does all of the packet capture and all of the analysis and all of the dashboarding and all of the visualization and all of the AI at the very best possible level for all of those things. It's a very difficult thing for any one company to build. So I think it becomes more about the ecosystem and the openness of the data and APIs. So it becomes more about how do you take the best tools for doing AI, the best tools for doing visualization, communication, LLMs, all of these kinds of things, and reducing the friction. So making it easier for these tools to communicate, get access to the large amounts of data that help AI and machine learning models to learn, rather than trying to put it in a box, in a glass box, and say, no, this is all isolated and you can't communicate with anyone else.
Aggregation, the concept of aggregating data means that you always have to look at the data the same way. And it's not always true. Like sometimes you want to go deep, sometimes you want to stay at the higher level. So one thing that we are using actually as a concept is to explore all the paths until we found what is the root error or the root cause. And we provide to the user the entire path, so they can go back and forth at different levels and understand better the why something happened. On top of that, thanks to recent advance of LLMs and retrieval augmented generative algorithm, this kind of algorithm can synthesize and you can actually ask questions to your system. And so dashboards might be outdated. So you can actually converse with the system and get the answer in a more synthesized way. And go in this path of going deep on or high very easily. And I think that's going to be maybe not now, but very soon, what we're going to see in many systems. Like you can actually act by interacting. You can ask, I want to see a diagram showing ABC, and then the system going to generate it. So you don't have to pre-think about all the combination of the usage of the system. So you can actually have this interaction.
Last question round. Let's assume 5 years from now we're gonna all sit in a wonderful presentation lounge with 600 people watching, and we're at the top of some high fancy building. What you guys see is the hot topic of that session. What is the hot topic of SharkFest? What is everyone talking about in 5 years in network analysis? Chris, let's start with you.
So 5 years is a long time these days, right? A lot's going to happen, like every day we wake up and something's different in the world of AI. I do think quantum computing is right around the corner, trying to keep up with that. And we're already seeing a lot of progress. It's, you're going to have possibly free energy. We've all read a lot about that. So in 5 years, I'm thinking that, if quantum computing actually becomes available, and probably it's not going to be on our iPhones yet, but it will probably be available in computing in the cloud, then the types of analysis that we can do is going to be, so far beyond, so the tools that we'll use, I've looked at some of the languages for doing quantum computing and I don't understand them at all. So we all got to go back to school for that. So I think it's going to be along those lines. There are going to be discussions that we're not even having now. I don't think it's going to be, about how much faster the things we talk about now are or better. It's going to be completely different, especially like visualizations are going to be different too.
Laurent?
Also, quantum computing will be a new topic. It will change the way we encrypt, decrypt, new encryption method. Also, I think SASE, zero trust will develop a lot. So that will be a complete new paradigm for network infrastructure. And I think that's where we go.
It's a very hard question because 6 months ago, I don't know what I was doing today, so it's going very fast. I have the feeling that, companies, telecommunication companies facing more threats, needs to provide a very good user experience, need to grow in revenue. So they are facing a big challenge, and they don't innovate very fast. We mentioned that. I think they're not going to have the choice to embrace automation more and to develop this kind of mindset of adopting faster. Otherwise, it's going to be a big challenge for them.
5 years is an interesting one. Someone once said that we tend to overestimate change in the short term, but underestimate it in the long term. So 5 years' time might be more like today than we expect it to be, right? We're still not going to have flying cars. I think AI will be a lot more familiar and a lot more common. It's going to be everywhere. The transition to cloud will be even further underway than it is now. As Chris said, that people are running towards cloud right now to save money. But we're also hearing about people moving some workloads back out of cloud because it's not cost effective, right? So if these very elastic workloads work really well in cloud, we can scale up and down, but a very static workload can be more expensive in cloud than out of it. So maybe we'll have a more mature kind of approach to what makes sense in cloud and what doesn't by then.
And then back to what Laurent said about zero trust, that just will make it more difficult in the cloud to figure out now what packets to capture. Do you really want to capture from every single workstation in your entire environment? And now how to deal with that much data. So awesome for learning purposes, AI learning purposes, but from an engineering standpoint, from an administration standpoint, try to just figure out where to sniff and in an already incredibly complex environment now, and now let's escalate that 5 years. I'm so glad I'm going to retire soon.
The thing that comes to my mind immediately is just kind of a joke is that, AI is going to use the blockchain to create self-driving cars and put everybody out of a job. But I think I've been around long enough, and I think most of you have been around long enough, that every time there's some advancement in technology, the number of engineers and minds you need working on that tends to increase, not decrease. Maybe it shifts from one area to a different area, but I see in 5 years just the need for IT engineers increasing significantly, especially if we keep using the technology, regardless if AI does the thing it says it does or not. Elon Musk promised me a self-driving Tesla, and I try to use it, and it's consistently putting me in dangerous situations. I can't imagine that the pipe dream of AI is going to lead to much in 5 years, other than maybe a tool that helps us and probably creates more need to do some quality analysis of what's going on.
Well, thank you very much, our very first panelists at Wireshark SharkFest conference. Give it one round of applause. We still have 10 minutes. Does any one of you have any questions to the panelists they want to ask?
The number of the sectors in Wireshark is some function reflecting the number of protocols used in the world. At the moment, we have about 2,000 sectors. What do you think? How this number will change in 20 years? In 20 years, will be twice as many, times as many, or maybe twice less?
So I believe the count is almost 3,000, and yeah, and will it be more? It's been 3,000 for a long time, so I don't want to extrapolate to 20 years, but I have noticed over the years that there are more. We have one case in this environment, and we need to specialize dissector for just that, and while there was someone who was awesome and wrote the dissector for that, and that use case, now all those people are very, very happy. That does not necessarily mean that affects 99% of the environment or the population. So what I foresee is more single use case type of dissectors, and things for the cloud, things like that, things for AI, things for that. So single use dissectors that are perfect for a single use. However, it may be 5 years until that type of environment rolls out to more of the population, more corporations, more government entities. Government entities are always slower to come into something. And, if you want to know what's going next, you look what has happened in the past.
So the question is also the second one. Thank you. If we gave the power to AI 50 years ago, in the creation of transmission protocols, so do you think there would be as many protocols as today, or did the human emotional creativity cause the fact that we have so many?
I mean, that's very philosophical, right? But if you look at the history of IT, oftentimes the ideas that people wanted to implement were limited by the hardware technology available at the time. So we end up in this loop, right? We've only recently come out of the time of how many wires did the first telephone have? 2. How many wires does a landline phone have in your house today, 100 and some years later? 2. And that was a limitation we had to work around because of the hardware. And I think that's just going to continue. It's not like the hardware that we have today or 50 years ago could have been, even with AI, could have been magically conceived of and able to be produced.
So let's do a quick poll. TCP is over 50 years old, right? Now, Quick's been RFC'd for 2-ish years, in out there for 13, 14, 15 years. Let's do a quick poll. How many of y'all block Quick in your firewalls? So now the question is, as time goes on, how many of those hands have changed? So 2 years ago, 3 years ago, how many of you blocked Quick? Let's see, a couple more. So it's slow. It's slow to change.
I would just comment that yesterday we all watched Roland create a new protocol using AI in 5 minutes. And I think that that was great. I think it's an example of why I would say in 5 years or 20 years, there's going to be an explosion of new protocols because anybody can create one. It's always been so hard. You write an RFC. I can hardly read an RFC, right? So now, you can just, think of it, describe it to ChatGPT, and then it'll have it, there's better tools. It makes it easier. All the kids are going to be creating new ones. So I think there's going to be a whole lot more protocols coming out.
May I just say that your 2 questions, when you put the answers by Ross together, tie in perfectly with our source code, because we never throw any protocols out. That's kind of a badge of honor to have those. And one of those protocols is the protocol for the network protocol of Doom. And Doom runs nowadays on a Lego brick. There's a small Lego brick that runs Doom. So this is actually kind of a tie-in. No one, when they wrote it, needed the fastest computer at that time to run it. Now you run it on a microprocessor that's smaller than a Lego brick, so you can put it into a brick, including an OLED screen. So, yeah.
Yeah, you heard Betty's answer and Chris's answer, and I think that illustrates that the number of protocols in the future could go either way. You could end up with thousands of them that are AI generated, or people could say, I have to deal with firewalls every day. I give up. I'm just gonna do this over JSON over HTTPS, and I'm done. And that we could end up with just this single protocol that everybody uses, or just this explosion of them. I couldn't tell you what we're gonna have myself. So
I just want to add something. Yesterday I was amazed by what you provide us as a demonstration how to create a new protocol. I think yes, AI can help you, but there is no lot of ordering to use it. So it's because Roland managed to use AI to build it. It's not because AI is capable of. So if we ask a kid to do the same, it's not going to be able to work. So we need experts in order to make it work. That's going to affect the growth. It's not going to be expansion. It's going to be limited by Roland.
Any further questions?
So, with the tendency of increasing amount of protocols and processes, with the virtualization, automation of processes, and with a software-driven approach to network management and network operation, do you see a tendency still looking or analyzing packet by packet by packet? You know, I started with 10 megs, we ended up at 40 gigs, 100 gigs, or even more. Or should we look more into the end-to-end processes that get automated anyways and maybe integrate in log files analyzed by AI plus the packets when it comes into that play? Do you see a tendency where this could lead to in the next 1, 2, or 5 years?
I strongly believe yes. We're going to go more granular, and the bet is each time you do an aggregation and you try to extract beforehand, you're losing information. So as much as you can, stay close to the lower granularity, and then the aggregation going to be done by itself using AI. So you don't need to pre-think about the way to aggregate data and make sense out of it, because thanks to the increase of power, computation power, I mean, yesterday Apple released a new chip which can allow you to train a large language model on your laptops. That's completely crazy. So this growth is continuing, and we will see this kind of compute power at the edge, and I think that's going to be the trend.
I would say if we look at voice over IP, it's an example of how we're going from packets to flows to calls, and I think we're going to see a continuation of that with bigger and bigger objects that are made out of those packets. I've been looking at packets like you guys for so long. I do get this odd, enjoyment out of that, but it's easier to solve a lot of the problems if I can avoid that and, look at a voice over IP call or look at a multi-tiered application where I've got, the DNS, and then I've got the web talking to the app, talking to the database. So I hope that we work our way up the stack, and the tools that we use and the way that we think is at a higher and higher level, and that we let the computers and the AIs worry about packets and bytes and things like that.
Do we still need to look at packets one at a time? I think it's a really good question. AI is great at summarizing and learning what's normal and what's not. So aggregating and summarizing data is really powerful. But on the other hand, you look at some of the recent attacks like the rapid reset, HTTP2 rapid reset attack. If the only thing that you were able to look at was NetFlow doesn't have enough detail in it for you to understand what that attack was and how it worked. You have to look at the individual packets. You have to get down into all those options in order to understand what actually happened. So, and particularly also given that AI models love looking at huge amounts of data, I think we'll be looking at packets for a very long time.
To being able to go ahead and, hey, I have that data store of packets. Now the best tool to look at it is with Zeek. Let's look at the weird log. And then now that I see what to zoom in on and use those tools to figure out what to filter for, then I can go ahead and see why is it happening, how to fix it, or how to block it. So being able to switch back and forth, one set of data, but many uses, many programs, many silos in the corporation, as far as, your security team, your dev team, your NetOps team working together.
Thank you very much, panelists. Thank you very much for the questions. Thank you very much for attending. I hope you have an enjoyable rest of the day for SharkFest, and see you in the next class.
Thank you for listening to this installment of the SharkFest podcast. If you want to stay informed about upcoming episodes, please subscribe to our podcast at YouTube or your podcasting platform of choice. My name is Roland. See you next time.